Hello, in this presentation I will show you how to construct and test a simple linear regression model with SPSS. I advise you to work along with me on the SPSS database called Adolescent Behavior 3, which is attached to this course. Briefly, to construct a simple linear model means to test the predictive value of a variable called predictor or independent variable upon another variable called criterion or dependent variable. The simple linear model is actually a linear function which is written as y equals b0 plus b1 multiplied by x. In this function, b0 represents the intercept, which is the value of the criterion when the predictor value is 0, and the b1 value is called the unstandardized regression coefficient, and it tells us with how many units of measurement does the criterion variable change when the predictor variable changes with 1 unit. It has also a standardized version called beta, which is measured in standard deviation units and which indicates how many standard deviations does the criterion variable change when the predictor variable changes with 1 standard deviation. As in the previous presentations, I will describe all the procedures that I will use, but I will not go deep into the statistical formulas. If you want to understand or to consolidate your basic knowledge about the simple linear regression, I advise you to enroll in another course of mine from this platform called Introduction to Statistics for Non-Mathematicians. So, let's begin. The objective of our analysis will be to find out if the social support perceived by adolescents is a significant predictor for their involvement in non-formal activities along with their colleagues. So, I will select Analyze, Regression, Linear. In this new window, you can see in the left side the list of all variables from our database, and in the right side, we have two main areas, one dedicated to the dependent or the criterion variable and one dedicated to the independent or predictor variables. So, I will introduce the involvement in non-formal activities as a dependent variable and the social support as an independent variable. This window has several options for more complex models, but for now I will not select them. From the Statistics button, I will choose only estimates for the regression coefficients and the model fit in order to have an evaluation for the quality of our predictive model, and I will click Continue and OK. Now let's see the results. In the second table, called Model Summary, we have the correlation of our linear model with the criterion variable, named with the capital letter R. As long as we have only one predictor in our model, the capital R coefficient is identical with the correlation coefficient between our predictor, which is social support, and our criterion, which is the involvement in non-formal activities. On the next column, we have the R-square, also called coefficient of determination, which multiplied by 100 indicates what percentage from the variance of the involvement in non-formal activities is explained by the social support. In our case, we can see that social support explains 1.8% from the variance of non-formal activities involvement, which is a rather modest proportion. Of course, having a correlation of only 0.13, which is a small correlation according to Cohen, we could not expect more. Next, we have the adjusted R-square, which is adjusted for the number of predictors. So, as you can imagine, this value becomes relevant only when we have more than one predictor in our model, which is not the case right now. We have also the standard error of the estimate, which in our analysis is not necessarily of high interest. In the third table, called ANOVA, there is another way of expressing how good our model is. The F value is the ratio between the explained variance, which is R squared, and the unexplained variance, which is 1 minus r squared. If this f value is significant, which means a p-value smaller than 0.05, it means that we have a significant predictive model. In other words, our linear model containing the social support as predictor is a better predictor for the involvement in non-formal activities than the mean value. In our case, the p-value is 0.000, which is less than 0.05, so our model is significant. In the fourth table, we have the coefficients for our model. First, we can see the unstandardized coefficient of regression, its standard error, and its standardized version. The unstandardized value is 0.034, which means that when the social support increases with 1 unit, the involvement in non-formal activities with colleagues increases with 0.034 units. The standardized coefficient has the same interpretation, but its unit of measurement is the standard deviation. So its value in our case is 0.13, which means that when the social support increases with 1 standard deviation, the involvement in non-formal activities increases with 0.13 standard deviations. The same row of the table includes the t-test value and its level of significance. The t-test actually computes the probability of having a zero value of this coefficient of regression in the population. As you can see, this probability, which is the p-value or the level of significance, is smaller than 0.05, which means that our predictor is actually a significant predictor. This table includes also the constant of our model, which is 6.6. This means that when an adolescent has a score of 0 for the social support, the score of involvement in non-formal activities with colleagues will be 6.6. So, briefly, these were the main procedures for performing a simple linear regression with SPSS. Don't forget to leave a review and see you in the next presentation.